Hey guys, welcome back. This lesson is for Tuesday, May 5th. I cannot believe this, but I'm looking over my lessons and we only have today's lesson and one more lesson and we're done with the information we're going to cover for the year. So, looks like starting Friday, we're going to start our review for the final exam. My plan is to take this on Wednesday. Let's see, that would be May the 13th. Okay, Wednesday, May the 13th is when we'll be taking our final exam. That'll give us Friday, Monday, and Tuesday to prep for that and to get all of our notes together, make sure that we know all of the material before we get into the test. So we have today's lesson, which is 11.6, and then we'll do lesson 11.7, and then that will be the new material, the rest, or the final new material that we'll cover for this year. So we have almost successfully made it through algebra, so hang in there. We got a couple more lessons, and I know it's difficult to learn some of these new concepts over video. But it seems like you guys have been doing pretty well and haven't had a lot of questions thrown at me lately. So hopefully that means that you understand everything and you're not having any difficulty with it. So let's take a look today at 11.6. I know we had talked about a quiz coming up, and we are going to take that tomorrow, Wednesday, the 6th of May is when we'll take our quiz, okay? We'll take some time today and go over those notes for that quiz and make sure that we're ready to do that. But for today, let's go ahead and open our notes to 11.6, least common denominator, okay? And we'll be looking at, we're on page number 425, okay? Dealing with the least common denominator. So we've taken these rational expressions and we've dealt with simplifying, multiplying, dividing, adding with the common denominator. Now we're getting into this, what happens when we don't have a common denominator? How do we find a common denominator for a rational expression? So today we're going to look at just this, how to find the LCD, okay? And then tomorrow's lesson, or excuse me, Thursday's lesson, will apply that to the actual process of adding and subtracting rational expressions, okay? So we're on page 425. You should title your notes lesson 11.6, least common denominator, and that can be found on page 425. So let's get right into it, okay? We can read through all of this, but truth is, it doesn't tell us anything new that we don't already know. So we're just going to skip to the bottom here, the steps on how to find the least common denominator. So let's look at these real quick, okay? There are three steps here that we deal with when we're rewriting our rational expressions with a common denominator, okay? So our first step here, and again, you can find this bottom of page 225, okay? Rewriting rational expressions with a common denominator. First thing we're going to do is we're going to factor, okay? And when we factor, we're talking about factoring each denominator, okay? So no matter how many fractions you have in your problem, you're going to factor each denominator completely, okay? So you're going to factor each and every denominator out completely, okay? Step number 2 is we're going to write the LCD. Now, if we need review on this, go back into your book on how to find the LCD, but you'll see we'll review some of this as we're going along here, okay? We're going to write the LCD as the product of the factors. Now, this is the deal, okay? This is the product of the factors. And I want to put this in here because this is important. The greatest number of times. Okay, and this is the greatest number of times it appears in when we're comparing all of the different factors for each term, okay? So we're writing out the LCD, and if you'll go back in your book and review this section, you'll see what I mean by this, but we're looking for the greatest number of times it appears in the factors, and that's how many times we're going to include it for our LCD, okay? And you'll see what I'm talking about as we go through here, okay? So step number 3 then is to rewrite each fraction. Okay, so pretty basic. So these are your 3 steps. Pretty basic, and as I said, we've covered finding the least common denominator. There's not really much new to this except that in these cases we're going to have rational expressions, and we'll see how we're going to break these down to factor them as we're dealing with these different things. So those are your 3 steps. Now let's take these 3 steps and let's apply them so we see what we're talking about, okay? So let's go back here, and let's say I've got 3/8, okay? We're going to start off real basic, and 5/12, okay? We're going to take our denominators of 8 and 12, and we're going to factor them out. What are my factors of 8? Okay, that's 2 times 2 times 2. My factors of 12 are 2 times 2 times 3. Okay, so I'm going to take these factors and I'm going to create my least common denominator from them. Okay, so my LCD, and I look at my factors of 8, okay, and 2 is my factor of 8, and it's used 3 times. This is the greatest number of times that 2 is used. 2 is used in 12, but it's only used twice. It's used 3 times in 8, so we're going to put it down 3 times because that's the greatest number of times that the factor of 2 is used in a number, okay? So 2 is used there. In 12, we see the 2, but that's already represented here, and then we see a 3, okay? So here's my LCD. I multiply these together, 2 times 2 times 2 times 3, and I get 24. 24 is my LCD, okay? Now, I'm going to take this and apply this to my fractions here, and this is how we do this. I take my first fraction of 3/8, okay? And I'm going to multiply this fraction by whatever I'm missing to get 24, okay? So we know in 8, we have all the 3's represented, but we were missing, or excuse me, all the 2's represented, but we were missing our 3, okay? So in order to get 24, I then have to multiply it by my missing factor of 3, okay? 2 times 2 times 2 gives me my 8, but to find my least common denominator, I also have to have a 3 in there. So I'm going to multiply this by 3, okay? By doing that, I get 9/24, okay? I do the same thing with my other fraction, 5/12. Now, what I was missing in 12 was I had 2 2's, but I was also missing I was missing an extra 2 in my 12. So I'm going to multiply this by 2/2, okay? So 5 times 2 is 10, 12 times 2 is 24, and I now have my new fractions of 9/24 and 10/24, okay? So we're basically going to take these fractions and multiply this fraction by whatever I was missing in order to get my common denominator. So in my 8, I had the 2, and the 2, but I was missing a 3, so I multiplied it by 3. In the 12, I had a 2 and a 2 and a 3, so I had a 2 and a 2 and a 3, but I was missing another 2, so I multiplied it by 2/2. So we're multiplying these fractions by what we're missing in order to get my my least common denominator of 24. Okay, so this is not a new concept. We've done this before, but we've kind of done it in maybe a shortcut type way. So I wanted to show you exactly what we're multiplying by, what we're multiplying each fraction by in order to get that common denominator. Okay, so that's a real basic form of how to do this. Now let's throw in some variables. Okay, the same process, but what happens when we have variables? So let's say I have x over 5y, okay? And then I have 4 over 3ay. I'm still taking my denominators and factoring them out. So my first denominator, 5y, my factors are 5 and y, okay? My second denominator of 3ay, my factors are 3a and y, okay? So I'm using these factors then to find my LCD, okay? So I take my first one, 5y and 5y. Y appears one time in both of these, so it only has to be represented once in my LCD. Then I've got 3 and a, and my y is already represented, so I don't have to put another y, okay? So my least common denominator is 5 times 3, which is 15, a and y. So here now is my least common denominator. So let's put each fraction over here so we can find what we need to multiply by in order to get our least common denominator of 15 ay. So I take my first fraction of x over 5y, and I look at my denominator 5y, okay? So in my LCD, I have my 5, I have my y, but I'm missing a 3 and an a. So I'm going to multiply by 3a, and that will give me my missing terms to create a least common denominator of 15ay. Okay, so my 3 times a times x is my numerator. Oops, excuse me. Okay, and my denominator is 5 times 3, which is 15, and a and y. Okay, so this is my first new fraction with my common denominator. Now let's do 4, 3ay. Okay, so I look at my denominator that I have, 3, I have this, I have a, and I have y. The only thing I was missing is 5, so I'm going to multiply this by 5 over 5. That gives me 20, 15 ay. So my new fractions then are 3ax over 15 ay, and then 20 over 15 ay. So we're looking at our original denominators, we're looking at our breakdown of our least common denominator, and then we're looking at what we have in our first denominator and what we were missing from our LCD, and that is what you multiply each fraction by to get your common denominator, okay? Hopefully that is broken down easy enough for us to understand. There's no questions there, because as we get into these bigger ones where you have to factor into binomials, this is going to be important. So let's take a look at one of these here then. Now remember, the process will still remain the same, okay? So if we get a little caught up, let's go back to our basic steps, okay? We factor, okay? We write our each factor out for each denominator. We find our LCD, and then we multiply each fraction by what we're missing in our LCD, okay? So it's the same basic steps. So let's look at one that's maybe a little difficult here. We've got x squared plus 5x plus 6, a little different than what we had in the previous examples. And this one we've got 3 over x squared minus x minus 6, okay? So we've got these two denominators here, and we're just going to factor them just like we normally would factor a trinomial, okay? So I take my first one, and I factor this out. How does this factor? Well, this factors to x plus 3 and x plus 2. Okay, hopefully we're getting pretty good on our factoring at this point. We've been doing a lot of factoring since we've learned how to do this, so we should be getting a good grasp on that. Okay, so I factor my x squared plus 5x plus 6 into my two binomials. I'm going to do the same thing to my second denominator. Okay, x squared minus x minus 6 gives me x plus 2 and x minus 3. Okay, now my next step is to find my LCD here. So I look at my first denominator, and I've got x plus 3 and x plus 2. Okay, my second one, I already have x plus 2, so I don't need to write it a second time. But I am missing x minus 3, so I'm going to add that. Okay, so this is my new denominator. Okay, so I'm going to take my original fraction of x over x squared plus 5x plus 6, and I'm going to look at what I had here. Okay, if this helps, what you can do is instead of writing it like this, you can write it using your factors. So we can put x plus 3 and x plus 2, because it's the same thing, it's just expanded so we can see what we have and what we're missing. So I look at my first denominator and I say I've got x plus 3, that's here. I've got x plus 2, that's here. So I'm missing x minus 3. So I'm going to multiply by x minus 3. Okay, and this will give me my full least common denominator. So I have x times x minus 3 over x plus 3, x plus 2, and x minus 3. Okay, now I know the question is going to come up. Do we have to factor this for our answer? Unless it says otherwise, you can leave it just like this. Okay, so this would be my new or not factor, but FOIL. This would be my new fraction here, okay? Unless it says otherwise or I tell you otherwise, this is how your answer will look for your first fraction. So you don't have to go back and FOIL this to get, your trinomials or polynomials or whatever. You can just leave it like this, okay? So let's do the next one. We've got 3 over x squared minus x minus 6, or we can write this as x plus 2, x minus 3, okay? Either way is fine. To me, this is a little confusing for me since this is what I'm dealing with here. So I would write this as x plus 2 over x minus 3, just so that I can see what I have here. Okay, so now I need to determine what I'm multiplying by to get my LCD. So I look at this, I've got x plus 2, that's here. X minus 3, that's here. I'm missing my x plus 3. So I'm going to multiply by x plus 3 over x plus 3. Okay, that would give me 3 times x plus 3 over x plus 2, x minus 3, and x plus 3. Okay, so my new fractions then are x times x minus 3 over x plus 3, x plus 2, x minus 3, and then I've got 3 times x plus 3 over x plus 2, x minus 3, and x plus 3. Okay, so common denominators, and then in the process, our numerators also change because we're multiplying by what's missing there. Okay, so that is the basic concept of this. Not real difficult. The idea is you just factor, and then you multiply. You find your LCD, and then you multiply by what's missing. Okay, so pretty simple. Now you'll come across cases where some of them will already be factored. Okay, you can't factor it any less than what it, or any more than what it already is. Okay, so let's take a look at one of these where we have some terms that need factoring, some that are already factored to its lowest term. What do we do then? Okay, so this will be our last example here. We've got y squared over y squared minus 1. Okay. Then I've got y over y plus 1, and then I've got 3 over y minus 1. We're going to do the same thing, write these out. So we've got y squared minus 1. That gives me y plus 1 and y minus 1. Okay, my next one is y plus 1. Well, that doesn't get any easier than that. Okay, that really doesn't need to be factored at all. Neither does y minus 1. But I write them out myself because then I can see clearly what I have and what I'm missing. If you don't want to go through this process of writing these out, you don't have to, but because they're a denominator, I like to see everything written out of what I have, so to avoid any errors by oversight. Okay, so I look at my first one and I've got y plus 1 and y minus 1. Look at my second one, y plus 1's already in there, y minus 1 is already in there, so my LCD is y plus 1 times y minus 1. So I take all three of these and I do the same thing as I was doing before. So y squared, and I'm going to write this as my denominator instead of y squared minus 1 so I can see what I have. Okay. And that is my LCD. So I don't have to multiply it by anything because my LCD is already present there. Nothing is missing. Okay. So then I would go to my next one. So this is going to be part of my answer. It already has my least common denominator in it. Then I go to my second one, y over y plus 1. Okay, and I look at what I'm missing. I've got y plus 1, but I'm missing y minus 1. So I'm going to multiply by y minus 1. Okay, that gives me y times y minus 1 over, sorry guys, I keep writing x instead of y plus 1 times y minus 1. Okay, so here's my second fraction, okay, with my common denominator, right? Then I take my third fraction, 3 over y minus 1, okay, and what am I missing? I've got 3y minus 1, and then I'm missing a y plus 1, so I'm going to multiply by y plus 1. And I do the same thing, 3 times y plus 1 over y plus 1, y minus 1. Okay, so here are my three fractions with my LCD as my denominator. Okay, so I would write all these three out here, and that would be my answer. Okay, so pretty simple on finding the least common denominator. Not real difficult. The hardest part here is really just going to be factoring. And then once you factor, you just make sure that the greatest amount of each factor is represented in your least common denominator. So if something, let's say if 3 is represented 4 times in one number and 2 times in another number, it has to be represented 4 times in your LCD because it has to be represented by the greatest number of times it appears in one number. Okay, so that's the little note there that I wanted you to take down because that's important. Okay, so as long as it's represented the most amount of times, you don't have to write it again when you get to the next number because it's already represented in there. All right, so we're looking at our homework here, practice 11.6, page 427. We've got find the LCD on 1 through 10. Okay, there's 4 there. Go ahead and do those. 3, 4, 9, and 10, the blue tabs there. Write the numerator for each equivalent rational expression. So here you're going through, you're doing the same thing, only instead of writing the whole fraction as the answer, you're just going to write what the new numerator is. Okay, and that's 11, 12, and 15. And then on 17 through 32 here, you're going to change the equivalent fractions having the least common denominator. So you're basically going to write the new fractions for each of these. On this, you only have to do 19, 23, 25, and 27. Okay, that should give us, let's see, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so do 19 and 23, 25, and 27. So that left-hand column there of blue tabs that continues on to page 428. So make sure you turn the page there so you don't miss those answers. So you've got 3, 4, 9, 10, 11, 12, 15, 19, 23, 25, and 27. Okay, so that'll be your homework for tonight. That's due by the end of the day on, let's see, what did I say today was Thursday? Because tomorrow, or excuse me, Tuesday. And then tomorrow we'll look at our quiz. Real quickly, let's go ahead and take a look at our quiz here. And I believe I might have gone over this stuff with you already, but if not, I want to take a chance or take the time to do that so that we know what we're covering here. Okay, so this should have been quiz number 34 over lesson 11.1 to 11.4. In the first one, 1 through 3, we're evaluating each rational expression at the given values. Okay, if the value is undefined, you write undefined. Okay, so that's numbers 1 through 3. Okay, numbers 4 and 5, you're indicating the values at which each expression is undefined. So remember, when we have to cancel something out, that's no longer it's considered undefined and cannot be put in your answer. So you take your denominator in this case. This is not the canceling section, I'm sorry. But you take your denominator and you put your denominator to equal 0. Okay. If it needs to be factored first, you factor it and then you put each factor it to equal 0 to find out what those numbers are that were undefined. Okay. So numbers 4 and 5 is finding the undefined terms there. Okay, and we do that by taking the denominators, setting them to equal 0, and then solving for x, and that number is your undefined. Okay, and as I said before, if you have to factor, okay, one of these you'll have to factor first, and then you take each binomial that you factored and set each binomial to 0, and then both of those answers will be undefined, shown on the line there. Okay, 6 and 7, we're just writing the reciprocal. That's when we take the fraction and flip it upside down. So this shouldn't be a real difficult quiz. I feel like we have a pretty good handle on it, but if there's any questions, you'll let me know, and we will take this quiz tomorrow, which is Wednesday. Let's see, that would be April 6th is when we'll take this, on Wednesday, April 6th. And this is again over sections 11.1 to 11.4. Okay, so that is the review for the quiz number 34 that we'll take on Wednesday. But as for your homework for today, make sure you get it handed in by the end of the day today. And one more lesson, and that's it. That's all the new material we're going to cover, and then we'll begin our review for our final exam at that point. So if you've had any questions, or if there's, as we're going through the review, if there's something that you would like to go over, have re-explained, let me know. Get a hold of me, shoot me a text or something, and we'll take some time and review those sections and work on it that way. Okay, I think that is all I have for you today, guys, and I look forward to seeing your homework. Make sure that you fill all of that out so you get a complete grade for today, and we'll move forward on that. All right, guys, have a good day. We'll talk to you later. Bye-bye.